Hello, my name is Michael O'Neill. I'm at the University of Hull, and today I want to talk to you about atomic structure. That's a C there. Good. Very professional start here. So what does a chemist need to know about atomic structure? Firstly, you need to know the crude makeup of an atom. In the middle of an atom is a really small, really hard bit called the nucleus. You might have learned about cells in biology, and you might see a nucleus in the middle of a cell in much the same way that you'd see a nucleus in the middle of an atom. The other crude bit of anatomy you need to know, that's a wiggly line there, is that around the nucleus, much further away, is an orbit of electrons. So, central nucleus here. Central nucleus is positively charged. Compare that to the electrons, which are orbiting around the outside. They are negatively charged. Good, glad you can hear me as well as see my handwriting there. And very crudely, this is what keeps the atom together. So, your nucleus has a big positive charge. Your electrons running around the outside, they have a negative charge. And this attraction between the two is what keeps these atoms together. So I use the word an orbit of electrons. That's very deliberate. You might see the analogy with the solar system here. So in the center of the solar system you'd have the sun. But around the edges of the solar system you would have planets spinning around, orbiting the sun. In the solar system, what keeps the planets from flying away is gravity. So the sun in the middle here weighs a lot. The planets weigh a lot too. And there's some gravitational attraction between these massive bodies. That's not quite true of an atom. In an atom, the forces keeping things together are electrostatic, so they're to do with electrical charges, sometimes called Coulombic forces. Coulomb, I think that's how you spell it. Who's a French scientist. But loosely, the analogy is there. Electrons orbit the nucleus in much the same way that planets orbit the sun. Chemists need to know a couple more things here. Both protons and neutrons are... Oh, let's have a grey here. Yeah. Inside the nucleus of an atom, there are protons, and there are also neutrons. Let me tell you a bit about those. These components of the atom, and that's really to do with their masses. So this is typically tabulated. We can look at the various particles, we can look at their charges, and we can look at their masses. It's a good table. Yeah. So, we know that electrons are one type of particle. There are two other types. One of these is called a proton, and one of these is called a neutron. And if we just flip back to the atomic... So protons are called protons. Ooh, I think we have a highlighting tool here. Maybe this? Yeah. You might have made a list of pros and cons, reasons for and reasons against something. Maybe deciding whether to stay in a relationship or whether to study chemistry at university. Protons would be the positives. And they're called protons because they have a positive charge. So in the standard sort of currency of chemistry, protons would have a +1 charge. Compare this with the neutrons. Ooh. Look at this highlighting skill. Didn't give me a doctorate for nothing. Neutrons have no charge. Okay, they are neutral in an electrical sense. That is why they're called neutrons. No charge, neutral. Let's call them a neutron. Maybe that's how that conversation went. But overall, an atom has no charge, and electrons are what balance that out. So electrons have a charge of -1. Electrons are negatively charged. And in most of the chemistry that you'll go on to do, electrons are really the things that do chemistry. So electrons are the basis of explanations for why metals are shiny, the basis of explanations for why things do and don't conduct electricity, and on a more profound level, they're really the basis of explanations for why things are the shape they are, why drugs can cure diseases, why other molecules can cause diseases. Chemistry has been described as the physics of the outer electron. That's not entirely true, but it's not entirely wrong either. So, masses. Protons and neutrons have the same mass, and I definitely know what that is. In terms of atomic mass units, this is the basic currency of chemistry again. It's 1. So 1 atomic unit is how much a proton weighs. A neutron weighs exactly the same. That also weighs 1 atomic unit. These units here are sometimes called Daltons. Dalton's DA there, named after John Dalton, a pioneering scientist in the work that was done on atomic theory. Electrons weigh a lot less than protons and neutrons. They weigh approximately 1/1900th of the mass of a proton or a neutron. So it's not far off weighing 2,000 times less. Is that true? 1/2000th of a proton or a neutron. Some people like to say the mass of an electron is negligible. it's not even worth considering it's so small. That is usually true. It's not always true. So that's my 2 cents there. In every chemistry course across the world, these are not really profound numbers. They kind of sink into the way that we talk about chemistry. And you're best checking for your own exam board. But it's usually the case that you will be provided with the precise masses in kilograms if you need them. So 1 atomic unit is a really tiny number of kilograms. But the contents of this table are something that every chemist, every single chemist, should absolutely know. So that's the basic anatomy of atomic theory. I'll see you next time.